Okay, so now getting into the examples. First of all, you're asked to identify each of the transformations, and we're going to use those transformations to do the graph and identify what the vertex is and identify the axis of symmetry. Okay, so if you look back, and I'm going to be pulling two pieces of paper back up forth here. Of course, this is the list of transformations, okay? Same thing that you would have written in your notes earlier. If you notice the location that you have here of the -5, that's going to be the situation here where I have -k. So the fact that this is inside the parentheses, and of course the minus, that means that this graph is going to shift to the right 5 units. So when I say identify the transformations, I want you to list that. So we're going to have right 5. Okay? Now, to graph it, back on the parent function that I had given you earlier, of course I had these 5 points marked. I made the comment, I said when we go to do the graph, we're just going to use these 3 here at the bottom. So I'm going to put these 3 points on my grid first. So the point 1, 1, 0, 0, negative 1, 1. So I'm just going to lightly mark those points. So 1, 1. I'll just use each grid line is just going to represent 1 unit. So there's 1, 1, 0, 0, negative 1, 1. So my transformation tells me that I need to take those 3 points and shift each one of those to the right 5. So you just simply count it off. So I'm going to start with this point that would be the vertex. So 1, 2, 3, 4, 5. And then do the same thing with each of these points if you shift each of these to the right 5. Now, this is the only transformation that you have here. So once you shift these 3 points to the right 5, you're done with your graph. Now you need to connect them up and make your parabola. So remember, your parabola is the bowl-shaped graph. So a couple things I want you to make sure that you do. As you come through these 3 points, make sure you round it at the bottom. It is not a sharp point. These are bowls, okay? They're nice and rounded at the bottom or nice and rounded at the top. The other thing is, as they go up, or if it turns upside down and they go down, it does continue to widen. So like, don't come out of this last point and just go straight up vertically. It continues to widen out as it goes up. Alright, then you're also asked to identify the vertex and the axis of symmetry. Now a couple things you can do with identifying your vertex, and I'm going to explain it both ways. First of all, you can just look at your graph. So now that we've got our graph done, the point here at the bottom would be the vertex, and that would be the point 5, 0. Now remember the note that I gave you. Let me find it over here. This note that you had written earlier where I said the vertex is HK, where H is the number from inside the parentheses and then K is the number at the end. So let's think about this in reference to this particular problem. See, the number that I have inside the parentheses, if I ask you that number, you would tell me -5. But if you notice, what I have down here is +5. But remember, that's the one that I told you that you're going to change the sign of. So you have a -5, but therefore you make it +5 down here. Now for the y-coordinate for your vertex, that comes from the number that's out here that's added or subtracted. But since I don't have anything here that's added or subtracted, it would have to be an understood 0. So that's where this comes from. Okay, now axis of symmetry. Now I talked about what that was. I didn't tell you as far as identifying it. So remember, your axis of symmetry, remember, it's this imaginary vertical line that cuts your parabola perfectly in half. First of all, since it is a vertical line, it has to be x equal. Okay? So always, axis of symmetry, always write down x equal. Then, the other thing I told you about your axis of symmetry is it always goes through the vertex. So all that you have to do to find the location for your axis of symmetry, and because it's x, is you get the x coordinate of the vertex. So the axis of symmetry is located at x equal 5. So if I were to dot in this vertical line, and you don't have to do this to be able to graph it. I'm actually done graphing it. I'm just showing it to you. But see, you would go on your x-axis to positive 5, and see that would be that vertical line that goes through the vertex, and it cuts the parabola in half. Again, the left side and the right side are mirror images of each other. Okay, next one. Okay, so figuring out what transformations we have this time. Now, let's talk about order here just a little bit. I didn't mention order a while ago because I only had one thing, that was to go to the right 5. But I've got two different transformations that I have here. Okay, first of all, the order says you're supposed to look for horizontal shift. That's left or right. The left and the right, remember, is always going to come from anything that's added or subtracted inside the parentheses. So plus 2, when you look at your list, having a plus 2, in this case plus k, means that it goes to the left. So left 2. Okay, next you're supposed to look for a stretch or a compression. So that's number 2 on my list. But a stretch or a compression, remember, you would have to have a number in front multiplied that's either bigger than 1 or between 0 and 1. And you don't have that. I mean, I do have a number in front multiplied, it's just an understood 1. But when it comes to a stretch or a compression, the times 1 doesn't change anything. Alright, next on the list was reflection. That would require a negative out front or a negative inside. You don't have either one of those. Last on the list you're supposed to check for is to see if there's a vertical shift. And the vertical shift means up or down. And see, that's what these two rules are. So after you have what's being squared, if you have something added or subtracted, that's going to be your vertical shift, either up or down. That's what your minus 4 is representing. So minus 4 or minus k, remember, means that it's going to go down. So this is going to be down 4. Now, I'm going to stick to doing my transformations exactly in this order. Okay, like I said, sometimes it's not going to matter, but sometimes it will. So I'm going to start off with the same 3 points that I started off with a while ago. Like those 3, you just need to have that memorized. Here's the 3 that I've got to start off with. So first of all, I'm going to shift each one of those to the left 2. So actually what's going to happen is this point is actually, when I shift it left, is going to end up on top of that one. So this point shifts to the left, this one shifted here, this one shifts on top of that one. Alright, so now I need to take these 3 points and move each one of them down 4. Okay, so this is my final graph. Okay. Now, identify the vertex. Again, 2 ways that we can do that. Of course, this would be the vertex, so you can just get it straight from your graph. So that would be to the left 2. So that means your x coordinate would be negative 2, and then you had to go down 4. So your y coordinate would be negative 4. Now remember, if you can also get it from your equation, remember it's hk. So let's see, in here is where you get your h, out here is where you get your k. Now your h in here, you look at this, you would tell me positive 2, but remember this is the one you got to change the sign of, therefore you have negative 2 down here. And then the value that you have here is negative 4, therefore I have negative 4. So you don't change the K, just the H. And then your axis of symmetry. Remember, it's always x equal, and it's always the number that it's equal to is going to have to be the x coordinate of the vertex every single time.